Classification and composition of particles. A brief introduction. In this video, I will try to give a brief outline of the classification of elementary particles and their quark composition. Let's start with particle classification. Well, in the very early stage, particles were classified according to their masses. So particles with comparatively smaller mass are called leptons, with intermediate mass are called mesons, and with comparatively heavier masses are called baryons. Moreover, as mesons and baryons are comparatively heavier than leptons, they are clubbed together into a single group which is called hadrons. So, there are two major groups of particles, leptons and hadrons. Again, hadrons are having two subgroups, mesons and baryons. Following spin statistics, elementary particles are also classified as fermions and bosons, in which leptons and baryons are fermions, that is spin half particles, and mesons and gauge bosons are bosons, that is spin integral particles. Now, what are gauge bosons? These are the field particles which mediate the interaction between the particles. This chart is a hierarchy of elementary particles with different groups and subgroups. Stating a few lines on the standard model is imperative here. Standard model of elementary particles is the guiding theory for three kinds of interactions, that is strong interaction, electromagnetic interaction and weak interaction, but not the gravitational interaction as yet. It has two fundamental participating groups, the matter, that is the massive particle group, and the interaction, that is the force carrier groups. The matter group contains leptons and quarks, and the force carrier contains the gauge bosons, that is gluon, photon, W plus minus Z boson, and the scalar boson, that is the Higgs boson. Let's understand a little bit about quarks and leptons. These are the most fundamental building blocks of our universe. There are altogether 6 quarks, up, down, Stein charm, top, bottom, and 6 leptons, electron, mu, tau, and their corresponding 3 neutrinos. All these 6 quarks and the 6 leptons had their corresponding antiparticles. As mentioned earlier, both the quarks and the leptons are fermions, that is spin half integral particles. Quarks have fractional electronic charge and so also are the antiquarks. Both the quarks and the leptons are generally classified into 3 generations. The 3 generations of the quarks are shown in the table. The antiquarks will also follow the same pattern of generations, but they will carry opposite charge to their corresponding quarks. Out of the 3 generations of the quark, the first generation, that is U and D quarks, have comparatively smaller mass, which is of the order of million electron volt. The second generation, that is charm and strange, have their masses in the moderate range, which is of the order of GeV, whereas the third generation quarks, that is top and bottom, have maximum masses, and in fact the top quark is the heaviest of all the 6 quarks with mass of the order of 175 GeV. Quarks never exist singly, that is they only exist inside a bound system, that is hadrons. The 2 major parts of the hadrons are baryons and mesons. Whereas the baryons are bound states of 3 quarks, mesons are bound states of quark and an antiquark. So leptons and quarks are the essential parts of the fundamental building block of our universe. Whereas leptons do not feel strong force, quarks feel strong force. So leptons, antileptons, quarks, antiquarks, these are the fundamental particles of which our universe is composed of, along with the field particles. So matter is composed of atoms. Atom has nucleus. Nucleus contains neutrons and protons, and neutrons and protons are composed of quarks, more specifically up and down quarks. Protons and neutrons are three quark bound system differing only in their combinations of up and down quarks. A proton consists of two up quark of charge plus 2 by 3 and one down quark of charge minus 1 by 3, giving the total charge to be equal to plus 1, whereas a neutron consists of one up quark of charge plus 2 by 3 and two down quarks of charge minus 1 by 3, giving the total charge to be is equal to 0. There are other particles also having fractional electronic charge. There is lambda baryon, which is composed of one U quark, one D quark and one S quark. There is delta baryon consisting of three U quarks. One can always calculate their charges from the individual charges of U, D and S quarks. Similarly, one can explore the composition, the charge, the mass of other baryons like sigma plus, sigma minus, etc. Mesons are two quark bound systems having a quark and an antiquark. Here also we can find their charges by exploring the compositions of different kinds of mesons like pi meson, k meson, d meson, b meson, etc. The vast zoo of elementary particles are arranged following some definite rules. It is really very fascinating to study, to explore, to understand how they interact among themselves. The fundamental questions which have driven high energy theorists to look for an exhaustive theory for interaction of hadrons are: what are the ultimate constituents of matter? How do they interact with each other? What is the mathematical theory of elementary particles? The standard model of particle physics stems from the naive effort to answer these questions. Standard model has been successfully tested at an impressive level of accuracy, and it at present is our best fundamental understanding of the phenomenology of particle physics. It is by far the generally accepted description of how matter interacts at very low scale and at a very high energy. But standard model can unify only three of the four fundamental interactions, that is strong interaction, electromagnetic interaction and weak interaction. Attempts are on to unify gravitational interaction along with these three fundamental interactions. This is the way science advances.